Okay, are the following functions, we did this in 5.5 in the last section, but it's very relevant today, so I'm going to review it really quickly. Okay, so if you've got three different x values, then I know, hey, all of those x values are going to be linked to their own special, unique y. I know when I hit the 4 button, I get out a 7. When I hit the 1 button, I get an 8. When I hit the 2, I get out a 9. So this is going to be a yes. Okay. When you have a repeat x value, that should raise a red flag. Now, if this said 1717, I'd be okay because I know what happens when I hit the 1 button. But here I've got the 1 button leading to two different y's. And then so, hey, my x values aren't each linked to a unique y, so this is going to be a no. Okay? Now, this is here. I do see I have two different y's, but that's okay. When I hit the 1 button, I know I get out a 9. When I hit the 2 button, I know I get out a 9. Yeah, they're the same thing, but if you think about these buttons, if these are buttons on a machine, I know what happens when I hit each of these buttons. There's no mystery like there would be on part B, where the 1 button, you don't know if you get out a 7 or an 8. So this is going to be a yes, okay? And then on parts D and E, when you have a graph, you can just, I'm just adding little arrows, you can just do a vertical line test. If you draw a vertical line anywhere on this graph, it's not going to cross the parabola more than once, maximum of one intersection. This passes the vertical line test, and that means yes, this is a function. This one is going to fail. If you put a vertical line right there, it fails, and it makes sense. This x value, if you look really closely, that's negative, I think it's negative 2. These numbers are so small. But if x is negative 2, then y could be positive 2 or negative 2. So that x value leads to two different y's. This fails the vertical line test. That's a no. Okay, so vertical line test determines if a relation is a function or not. If it passes the test, it is a function. If it does not pass, it is not a function. Okay? That's the vertical line test. Okay? We're going to talk about the inverse of a function. Okay? So this kind of printed out a little weird here. That is not just f to the first. This is supposed to be f to the negative first of x. Okay? Just in case that's hard to see there. There should be a little negative in front of the 1. Okay? So this is just a way to say the inverse of x. We're not actually raising anything to the negative first. So notice how the negative 1 exponent is not out here. That would be different. That would just be raising the input to the negative first. But this is just a symbol to mean this is going to be the inverse of function f. Okay? So on this graph, let's say that this graphed one is f of x. This is our original function. Okay? And the first thing we want to do is graph the inverse of this. Okay? Now the inverse is going to be a reflection over the line y equals x. So it's important that you know what the line y equals x looks like. So think of it in y equals mx plus b form. I could write it like that, right? That would mean my y-intercept is 0 and my slope is 1, or 1 over 1. So up 1 to the right 1, up 1 to the right 1. Okay, y equals x is going to be a diagonal line that looks like this. So I'm going to reflect this over this line y equals x. You might remember doing this in geometry. We did this in geometry, okay? So the easiest way to do this, you can do it visually, but it's a little hard to get the, it's going to end up over here somewhere, okay? If you think about folding the paper in half over this line, and if the parabola were painted in wet paint, it would leave another parabola over here kind of opening to the right, okay? But a nice way to do this is by using the xy pairs. So this is printed really small, but that's the point 0, 2. If you're reflecting over y equals x, you can just switch the order. So this point reflected over y equals x is going to be 2, 0. So if 0, 2 is on f of x, 2, 0 would be on the inverse of f of x, okay? And the same thing with the other point. So I've got negative 1, 3 labeled up here. If I just switch that xy pair, that's going to be 3, negative 1. 3, negative 1 is right here. Okay, and instead of 1, 3, I'm going to get 3, 1. And then you can probably see what's going to happen, right? We could keep going on with more points, but it's enough to see what's happening. We've got a parabola opening to the right from the point 2, 0. Okay, and this would be the inverse. So this is the inverse of f of x. Okay, then we've got two other questions here related to this graph. Now that we've got this graph, it's pretty easy to do. Is f of x a function? Well, this is going to pass the vertical line test if I'm just looking at the original parabola. So my answer is yes. Okay, is the inverse a function? Well, this would fail the vertical line test, and so that means we've got a no, that's not a function. Okay. Okay. On to the next page. So we were using the vertical line test there, okay? But there's also a horizontal line test, okay? For this next example, let's say that this is our original function here. This is f of x, okay? So is f of x a function? Well, hey, I can use the vertical line test. That fails the vertical line test, so that's going to be a no, right? Okay, so one way to handle this problem is to graph the inverse of this and then do the vertical line test again. But that's kind of a pain here. You could do that. It's not really that big of an issue, but it's going to be easier sometimes if you don't already have the graph of the inverse of a function to use the horizontal line test, okay? Because this is going to, it determines if an inverse is a function. Okay. All right. So the horizontal line test, it works the same as the vertical line test, except we got a horizontal line. Okay. So if it passes this, then this is supposed to be f of -1 there, right? Then the inverse, if it passes, the inverse is a function. If it fails, the inverse is not a function. Okay, and just to make this clear here, these are supposed to say f -1 of x. They're the inverses. So the horizontal line test you use on an inverse. The vertical line test you use on an original function. Okay, so horizontal line test, this passes the horizontal line test. So my answer here is yes. And hopefully parts A and B there kind of illustrate when to use the vertical line test. On the original function, that's when you use it. When to use the horizontal line test on the inverse of a function, okay? All right, so let's look, sometimes we don't deal with the graphs at all. Sometimes we're just looking at equations. So if we want to write the inverse of an equation, what we're going to do is switch the xy, the x's and y's, just like we would switch the xy pairs to graph the inverse, okay? And then we're going to solve for y, okay? So let's try that out. So, you know, I don't have a y here, but the f of x is more or less the same as the y. So you can just think of that like so, right? So what I want to do next is switch the x and the y. I'm just going to take these and swap them. Okay, so this is the inverse of this. I just want to write it in y equals form. Okay, so I'm going to have to isolate the y. So first thing I want to do is get rid of the radical so that I can get the y out of there. So I'm going to cube both sides of the equation here. So x to the third will equal y plus 1. Okay, now y is almost isolated. I'm just going to subtract 1 from both sides next. Okay, and now since you could leave it like this and it wouldn't be the end of the world, but since the original function is in function notation, that means I'd probably want to put this back in function notation. So instead of y, I'm going to use f of x form. And now I'm writing the inverse of this, right? So remember, this is the inverse. I hate how these print out. You can't really see the little negative, but this is supposed to, again, say that, okay? All right, so, and then you could write it just like it is here. I'm just going to flip this around so that I've got it written like that. Okay, there's my inverse. Okay. All right, let's try it again, switching the x and the y here. So this would be my y, right? So I'm going to put the x in that position, the y in this position, and then let's isolate the y. So first thing, add 3 to both sides. Okay, and then I want to take the square root of both sides. Now I'm taking the square root of both sides of an equation here, so you want to be careful. It's not just this, because then you're only taking the positive root. When you take the square root of both sides of an equation, got the positive and the negative, okay? And then I'm going to put this back in function notation. Okay, so most common wrong answer on a test would just be forgetting the plus or minus, so be careful there. All right. Okay, last page. Okay, I got 2 different functions. First, I'm going to find fg of x. This is sometimes written like this. It's f times g of x. So that means we're taking f of x times g of x. This is something that we did earlier in the chapter. So I'm just going to substitute f of x in here and g of x in here. F of x is 2x squared. G of x is x plus 4. And then I'm just going to actually simplify that, multiply them back together. So, hey, I'm going to distribute the 2x squared here. That's 2x to the third plus 8x squared, and done. There we go, okay? Sometimes you'll see this is f of g of x. This is different, okay? So sometimes you'll see this one written with an open dot between the f and the g. And that, a lot of times people think, oh, this is just must be multiplication. I don't know why it's an open dot, but it's just I'm just multiplying, so I'll do this. But this really means f of g of x. It's g of x inside of function f, okay? So here's how I'm going to handle this. Work from the inside out. So I'm going to take, I know what g of x equals. It's right here, right? G of x is x plus 4. So this is going to be f of the quantity x plus 4. Okay, so now what I'm going to do, this is my input for function f. So in function f, I'm going to replace the x with the quantity x plus 4. Okay, so 2 times the quantity x plus 4 squared, right? It's 2 times something squared. My something is x plus 4. Okay, and then I'm going to go ahead and simplify that. If you put a box around it there, I wouldn't be too sad about that. But we could simplify this. So we could write this without parentheses. Don't just square both terms. You'd want to FOIL this, right? So x times x, that's my first. Outer is 4x. Inner is also 4x, so that would give me a total of 8x. Last, 4 times 4 is 16. And then I could distribute the 2. So this is a better answer. It is simplified further. But sometimes the book will give you an answer like that as well, okay? Which isn't incorrect, it's just not simplified quite as much. All right, now f of g of x isn't going to be the same as g of f of x. I'm not going to get the same solution out here. Let me just do this so I separate my work here, okay? And again, you might see this written with a little open dot between the g and the f like so, okay? All right, so let's start on the inside and work our way out. F of x is 2x squared. So this simplifies to g of 2x squared, okay? And that means this is my input in function g. So my input, so I'm going to, in function g, I'm going to replace the x with 2x squared. So I've got something plus 4. My something is 2x squared. Okay, and there's actually nothing else I can do with this because these aren't like terms and there's no parentheses or anything. So no reducing to do. So you see we got very different things, g of x and g of f of x and f of g of x. Okay. So there's something, so this is called a composition of functions when you've got a function inside of another function. Okay. So parts B and C, those are both compositions of functions. Okay, and then we've got something called the composition functions test. Okay, if f of g of x equals x and g of f of x equals x. Notice they don't always equal the same thing, like on this last example, right? But if they do equal the same thing, and that same thing is x, then the two functions are always going to be inverses of each other. Okay, so that's how we're going to use the composition functions test. So this says test by composition if these are inverses or not. Okay, now there is a way to figure out if these are inverses without the composition of functions test. You could just take one of them, switch the xy pair, find the inverse, and see if it's that. And if it is, then hey, they're inverses. But that wouldn't be using the composition of functions test. So let's try to use the test. So it's a two-step thing. I've got to check if f of g of x equals x first. Okay, so let's go ahead and try that out. So I'm just kind of keeping track of what I'm doing. I'm going to find this part first. Okay, so I'm going to replace the g of x with the fraction, right? F of x minus 4 over 2. Okay, and now I'm going to input this into function f, where the x is. I'm going to replace the x with the fraction. And then I'm going to start simplifying. So, hey, the 2's cancel. Isn't that nice? So now I've got x minus 4 plus 4. Well, the 4's cancel. So, hey, this equals x. So, hey, phase 1 of my test, I've passed. So far it looks like they're inverses, but you can't just stop there because sometimes it will work in one direction and not in the other direction. So I still want to check g of f of x as well. If this failed, I could just stop. If either one of these tests fails, I can stop and say no. But if one of them passes, check the other way to make sure the other way works too. Okay? So f of x is 2x plus 4. So this is g of 2x plus 4. So I should have put my equal sign there. Okay, and now I'm inputting the quantity 2x plus 4 into function g. So where that x is right here, I'm replacing that with the quantity 2x plus 4. Okay, right? I had something minus 4 over 2. The something is 2x plus 4. Okay, let's start simplifying. Hey, in the numerator, the 4's cancel. 4 minus 4 is nothing. And then, hey, the 2's cancel. And this comes out to x, so hey, it passed my second leg. So my answer is yes, they are inverses. Okay. All right, you can pause it and try the next one out. So a lot of people look at this and think, oh, yeah, it kind of looks like they're inverses, but don't go based on looks because it can be deceiving at times. Do the test. Okay, g of x is the quantity 3x minus 2. I'm inputting 3x minus 2 into function f. 2 times something plus 3, right? Something is 3x minus 2. Okay, let's distribute the 2. And then that simplifies to 6x minus 1. Well, that doesn't equal x. This fails this leg, so I'm not going to do the other leg because it doesn't matter. They have to both pass, so my answer here is no, they're not inverses. And that is it. See you next time.